Using the power of noticing, creativity and exploration to promote algebraic thinking. I'm going to look today at patterns, representations, and symbols and gestures. I had another aspect that I was going to look at as well, but as I was going through it, I thought, I think I'm running out of time. So I just want you to know there was a fourth one. It does exist. If that interests you, I can tell you about that later. So these are just different ideas from patterns, representations, and symbols and gestures. I hope that something excites you. And that there's something you can take away and it inspires you to do a little bit more research and a little bit of an exploration yourself in your own classroom. So algebra, what do we think of when we say algebra? What do our students think of when we say algebra? I mean, a lot of the time we think about the symbolic representation, representing patterns through symbols. And I've taken that phrase from the draft curriculum. In this presentation, I'm going to keep dropping in phrases that are found in the curriculum just so you can see where they are, if that's of interest to you. I'd like to say that don't forget that algebra can be informal symbols and formal symbols. And this is a great inroad into algebra. Here's an interesting statement. The written representation comes after the doing, the noticing, and the describing. If you're at the beginning of exploring algebra with your students, then this statement is definitely true. You want the written representation to come after you've done the doing, after the noticing, after the describing. If they're a little bit further along the path, then well, you can mix it up a little bit, and that's the great thing about mathematics. You can start with the written representation and then do some doing, some describing and noticing. So algebra allows us to generalize, which is about expressing ideas which are always true. That's from the draft curriculum, page 25. Love that word always, and I'm always listening out for that word in my classroom and other words that are about the same idea. So when we're doing algebra, what evidence are we looking for to know that students are thinking algebraically? Because let's be honest, we can't actually open up their heads and actually see what the thinking is. So how are we actually what evidence are we actually looking for? I propose, this is not my idea, this comes from research, that the evidence that we look for is what students are doing and what students are saying. This is the evidence that there is algebraic thinking happening. So what could this look like? Well, what are they doing? Are they predicting? Are they making conjectures and testing conjectures? Are they finding a rule, following a rule? Are they finding what's the same, what's different? What are they saying? Are they saying things like, this always happens here? Are they saying, this always comes next? Are they doing some algebraic reasoning? If I do this, then this always happens. If I know this, then I know that. These are the sorts of things that give me clues that algebraic thinking is happening in the classroom. The recording of this session will be made available when all the other recordings are made available, so you can come back and see some of these points again if you like. I'll also have a PDF of a whole lot of links that you can look at where some of these thinkings come from and some of these activities come from. So I'm not going to talk a lot about this page, but these are the things that I love to hear in a classroom. I love to hear students discovering for themselves, because they can, about commutativity, about the associative and distributive rules, about inverse, the fact that there is with operations, there is an inverse operation that will undo it, about equivalence, about how both sides of the equation balance, and related to that, compensation. So if I know 5 and 5 is 10, for example, then if I take 1 from the 5 and put it on the other one, and so that one goes one more to 6 and the other goes one less to 4, I'll still reach 10, that compensation. Successor relation plus 1, and the identity, adding and subtracting 0, the number will stay the same. So this is all page 27, and we want our learners from year 3 to know a lot of these things. Isn't that great? I just can't wait to see solid learning happening being from that age. Perfect. If you want me to talk more about that at the end, I'm quite happy to, but I want to keep going. So patterns. Patterns are super important. I notice that there aren't any junior teachers here, but this is the slides that I've got prepared. So during the first 6 months, a big emphasis: copy, continue, create, and describe a repeating pattern. Go on a pattern walk. I really recommend going on a pattern walk and just encouraging that sort of noticing, the describing, getting that words about repeat, all those things about what your expectations about what your learners can talk about in terms of pattern. Back in the classroom, you can make patterns with anything. Okay, you can make them with really interesting items. The first thing, copy. I'm just taking note that copy is a matching exercise. I'm matching the first one, second one, and so on. It's a great lead in. You got anybody that's not understanding pattern, start with copy. It's a matching exercise. Then we move on to continue. Now, continue is where you actually are finding the rule. You're predicting what comes next. You're explaining. It's rule finding, the beginnings of algebra, super important. What about creating? Get that creativity going, making your own pattern. There is some talk about the fact that an AB pattern is a little bit harder sometimes to find the unit of repeat of the pattern because of its constant alternating. So let's look at this pattern here. Now, the interesting thing about these patterns is they have something the same about them, even though they're made of different items. So the same pattern structure can be found in many forms, for example, numbers, shapes, colours, and rhythm. That's page 27 of the draft curriculum. So one thing about tying all of these patterns together is if you show, if you represent it symbolically, then we can see the advantage of algebra, because we can see and we can talk about an ABB pattern and how these are connected. Finding the rule for a pattern, I need to work out what the unit of the pattern is. This is super important. Now, there's some research being done by Riddle Johnson in 2016. Patterning knowledge is a key indicator of later achievement. So finding the unit of pattern, some people call it the unit of repeat. That's the smallest amount that's been repeated here. And obviously these are quite simple patterns, and I know a lot of you are older teachers, but please just take the essence of it. So the unit of repeat there, the green, red, yellow, this is a key piece that they need to know. And once they've formed it, there's so many things you can do. One is measuring the whole pattern by the unit of repeat, and that links into measurement. So the measurement of the entire pattern there is 3, not because there's 3 items, but because we could take that unit and place it 3 times. So that's a great one. You can get kids to make their own just simple unit of pattern, give it to a buddy, and they have to create the entire pattern. There's lots that you can do there. This is just an example of a mistake, and so you can do spot mistake and again get more language, more talking, more noticing. You really want them to notice pattern. This one's an interesting one. So this is about using I can't think of the word, non-identical items. And I think that what I'd like you to take away from this is it's really important what examples we're putting up. for kids. I know that these are much younger a sort of format than a lot of you are working with, but what examples are you giving your students? Because this example actually creates quite a bit of rich discussion. So if you look at the green items, we're ignoring the different shape and we're stressing the color. And the red items, we're ignoring the different size and stressing the color. So this is really important. What is the importance of this pattern? It's only about color. We're not concerned about the fact that the items actually look slightly differently. That's an important discussion, I think, with patterning. Take your linear pattern and put it in a circle. And obviously you have to make sure that it's still correct and it still follows the pattern. Different view, and just getting kids to think a little bit more creatively and outside the box. A lot of checking going on. This one is just this example here is the example of two levels of task. So both of them, we want you to find the missing item or items. The one on the left obviously is easier. You might think it's easier because it's colored, but the other reason is we have a full unit of pattern here and a full unit of pattern here. And so it's easy to figure out which one is missing. But the one on the right, okay, it's with letters. You could consider that harder, but there is no complete unit of pattern for you to go from. So this one, because there's C at the end, we go, oh, A, B, B, C, will that work? A, B, B, C, A, B, B, C, yep, that will work. So when you first introduce a unit of pattern, finding that unit of repeat, it's important that your example has a complete units of pattern. So you're not ending what you're showing partway through a unit of pattern, if that makes sense. Sure. Well, okay, this is just something that I did with my class and got the creativity going. And so here's their pattern with Cuisenaire rods down here. That wasn't difficult to do, but then I brought out the instruments and it brought some creativity. So she decided this, she's from her view, it's blue, pink, orange, blue, pink, orange. She decided this was blue, this note was pink, and this note was orange. And she played it for me a couple of times. Each time it was the same, so that clearly was certain for her. Over here, we've got a Unifix cubes, red, yellow, and they were doing it collaboratively with maracas and tambourines. Other ones were using body patterns. And so you can see there's this lovely ability to go from something concrete to then you could actually be writing it with your informal symbols. It's just a very easy flow there and highly creative, very engaging. Now, this is an interesting image. Yes, it is from early childcare. I think it's really, really important, excuse me, for learners for us to talk to learners about noticing things. But what actually happened here is that the teacher was noticing. They had all these cable reels outside, and a lot of the children got them together and they formed this pattern. I'm going to describe it like this. So we look at it from this view. This is a column of 1, and then this is a column of 2. It depends which way you look at it. I just want to describe it this way. This is a column of 3, 4, 5. So if you look at it from above, you can see it's potentially got a staircase view. Now, what actually happened was the teacher noticed what the students were doing and took this as a springboard to do a whole lot of work on staircase patterns, which of course are not repeating patterns like the other one, but growing patterns. And I actually think this is, I was just getting these slides together and I thought, actually, this is worth talking about because patterns are everywhere. They're just everywhere. People love patterns in music, art, dance. We'll look a little bit at that a little bit further on. It's throughout it's just right across the world, and everybody's involved in pattern. Are we actually taking advantage of what our students are already interested in pattern and bringing that into the classroom? And this is an example of that. And there's another example later on as well. Here is, we've got Pacifica and Māori artistic patterns, and you could just have great fun exploring these. You could have black and white paper versions which you cut up and represent in different ways, looking at different ways that the patterns go together. You could be creative. You could actually make these as well, but definitely describe what's happening. Getting back to the staircase, the tool that the teacher used was Cuisenaire rods, which are really astounding for this. And he didn't, or what I suggest is that you don't just say, can you make a staircase, but you actually let your students explore. But they will discover the staircase because Cuisenaire rods are 10 rods, they're all different colours, but everything that is yellow is all the yellow ones are all the same size, and that's true for all the different colours. They're all, if they're a certain colour, they're the same colour, the same size as all those other ones of the same colour. So everybody can make a staircase. And this is, of course, is a growing pattern. Oops. Oh, sorry, I have done a crazy thing of jumping ahead by clicking on the wrong area. Okay, so looking here, this is the part where it's repeated. It's the gap from one stair to the other. And the gap between every stair is constant. And this is because Cuisenaire rods have been made to show the structure of our number system. And the difference from one whole number to another is +1. And this we can see very clearly with Cuisenaire rods. So a fantastic tool for that. Here we have a different growing pattern. Of course, the difference between each term is not constant. And you can see that it's square numbers. How great to go and have an explore with all the different types of patterns that you can do with Cuisenaire rods. Okay, some children really like radial patterns. If you want to explore those, pattern blocks are really fantastic for that. And in the PDF, I'll send an example of a document with lots of ideas that you can do with that. Right, Sinapi Payol worked in Nainai College, and with her year 9s, she discovered that they weren't that engaged in mathematics, but they were very engaged in Poly Club, and they would often break out in class with a whole lot of Sasa patterns. She herself was very passionate about Sasa as well. And so she decided for her geometry unit that she would bring Sasa into her mathematics class. And I'll put the link to this article in the PDF. And so what she did was she took some photos of some Sasa moves, and all the students talked and analysed the angles that were involved in those, and then they had a task, a challenge that they had to do, come up with their own routine. I imagine that there were definitely terms and conditions that I imagine, or criteria I should say. I imagine that they had to record it symbolically. So all of this is about pattern and algebra. Sinapi's colleagues were really excited about what she'd done and were trying to think about how they could do something similar. Her suggestion is, if you're moving into an area that's not your own culture, that you seek out the expertise from your network, and that you do so with respect. So it's just really delightful to see what other teachers have already done. This is Susie Cato, and during lockdown, when they had the home learning on TV, she was doing a session exploring and creating repeating patterns with the Samoan Sasa. Now, I wasn't able to actually watch this link anymore, so I couldn't actually find it. I find other things from Susie Cato, but not this one. So if you find it, I'd love to hear about it. But you can see on the right that she's written XXO, so I'm going to presume that that might be slap, slap, clap. But in any case, she's using informal symbols, and a great way to introduce that algebraic and how we record symbolically what we've done and what we've noticed. And according to the byline, it says that they were creating their own as well. Okay. Okay, now, this is what I want to get to. Okay, I want to show you a short video clip. This is from Dr. Schaefer, who teaches mathematics in Canada, and Eric Stern, who teaches dance in Utah. And they love to choreograph things that show the connection between dance and mathematics. And what I want you to notice is that they have a little motif, a little theme, and then they repeat it with variations. So they travel to the right, they do some arm rotations, and then they travel to the left and do some arm rotations. And they repeat this, but with some variations. So let's just watch that. It's just a short clip. All right, so that was just a very short clip showing what they've done. And I'm interested now in your reactions. Feel free to write in the chat, what are your reactions to what we've looked at so far? What would you use any of these ideas? Have these inspired you, or do you think, oh no, that's just not what I was looking for today? I'd love to see your reactions in the chat. I may not be able to read them all right now while I'm talking, because I'm going to keep going, because I know that we've already been waiting to get started, but I'd love to hear your reactions to this so far. You might be thinking, well, what's it got to do with algebra? Well, I would like to suggest that each of those dance moves that they did were, every time they repeated it, they were the same length. And so when they did it with variations, what they were doing was they were taking some of the dance moves and substituting it for another move that was of the same length, of the same value. And substitution is a part of algebra. The other thing they were doing is if they were traveling to the right and then traveling to the left, they were ending up back at the same position. And this is an embodied experience of an inverse operation. Our students learn through, we all learn through our bodies, but young people particularly so, we learn through our bodies. So these are great embodied representations of inverse operations. They rotate one way and they rotate the other way. They end up back at the same spot. So yeah, so it's the doing, the undoing, and also the substitution, I think, is very algebraic. So I would love to see your comments. So please just keep writing them. All right, I want to move on to representing. So representing enables a deeper and more flexible understanding of mathematical and statistical ideas. How does it do that? Well, here's an example of a representation on the right, and using something like this can help with the sharing of ideas, the developing of ideas, clarifying, and questioning. So if we look at this representation on the right, what we've got here is a whole lot of pegs. And if we decide that we want to see how many there are, we can't quite view them all, and we've decided we're not going to count, we're going to calculate. How could we do that? Well, we could look at the top layer and say, okay, well, there's 4 times 2 on the top layer. So if this is the top layer, how many layers are there? 1, 2, 3. Okay, so we've got 2 times 4 times 3. Well, I may have said it the other way around, but anyway, 2 times 4 times 3, and that is 24. 2 times 4 is 8, 8 times 3 is 24. But that's not the only way we could look at it. We could slice it a different way. We could slice it vertically there. And now we're looking at the front, and we can look at that representation. That's very easy to see it as 4 times 3. And how many slices are there? 2 slices. So now we've got 4 times 3 times 2. And 4 times 3 is 12, times 2 is 24. So what we've shown here is, of course, the associative rule. And what I'd like to point out about what's happening is, yes, it's the associative rule, and we could explore that just numerically with the symbols below. But by embodying these big ideas through representing and exploring cuboids and pegs, the understanding becomes deeper. Because while at the bottom we see the symbolic representation shows it really concisely, what the concrete representation provides is insight as to why. Okay, so that's one example of representation. Imagine if you'd done that example in your class or something, you had some other concrete representation of the same ideas. The associative rule, 2 times 4 times 3 equals 24. We've shown that when we're multiplying three numbers, the order that we multiply them in doesn't matter. How could we generalize it so there is an even deeper understanding? Pop your ideas into the chat about what you would do. In this situation, you have one example. How would you help them and move them towards generalizing it for a deeper example? I'm going to keep going. All right. Now, what about moving an easy bridge, moving kids from concrete resources into the abstract symbols? Well, one thing that's been shown to be very helpful is the bar model. And I'm just going to very briefly go through this. So we've got a representation here of Mr. T's class. He's got 3 times the number of students as Mr. R's class. And altogether, they have 28 students. So this now is showing us what the problem looks like. We don't know how many are in Mr. R's class or how many are in Mr. T's class, but we know the total is 28, and we know Mr. T has 3 times the number of Mr. R. So we can see from the representation of the bar modeling that each of these parts is the same size. So we're going to take 20, and there's 4 of them. We're going to take 28 divided by 4, and we come up with 7. And Mr. T's got 3 times that amount, so he's got 21 in his class. The quantities in the problem can be seen, and this is exactly what happened with the concrete representation as well, is students can retain a sense of quantity. As for using the bar model, the advantage here is that the algebra of the problem, what to do, how to solve it, the fact that there are 4 the same size can be visually seen. And so it's easier to see that we're going to divide the 28 by 4 to help solve that problem. Okay. Right, I've got another question for you to write in the chat. Who uses bar modeling already? Yeah, just pop it in the chat. That would be great to see later. Symbols and gestures. Okay, now what I want to talk about with symbols and gestures is some work done by Alf Cole. And as you can see from the next slide, he uses the Cateno chart. And what I'm going to do is I'm going to read some excerpts from Enrich Maths, Journeys on the Cateno tens chart. Now you can read further about this. There's some links on the PDF. Alf Coles did a video where he was talking to maths educators about the work that he'd done with this. It's called the Brown Bag series, and you'll see the link on the PDF. He's also done articles with Natalie Sinclair who also used the Cateno chart in a French immersion class in Canada. But this Enrich article is actually quite a good summary of what happened. So this is a picture of part of the Cateno chart. I'll show you the full chart in a later slide, but this is what he used with some of the younger students that he was working with. It was part of a project. They used to have artists in schools, and then for one particular year, they chose to have mathematicians in schools, and the idea was to get more creativity into mathematics classes. I find this really intriguing because looking at the Coutinho chart, you sort of think, well, how do you get creative here? But let me read you some of these excerpts. So what they were trying to do was have students asking their own questions, students follow their own lines of inquiry, students noticing patterns, making predictions and conjectures, and students choosing and sharing methods of representation. Now, Rachel or Robin, one of you willing to be my vocal guinea pig?
Yes, very happy.
Okay, thanks, Rachel. So when you first introduce the Coutinho chart, you generally have the chart, maybe it might be on an interactive whiteboard, but it could just be, written up on the board, written up on chart paper, and you generally have a teacher's pointer, and you're pointing to numbers and asking students to just chant them, basically. I'm just gonna, I'll try it. Sometimes, the photos are in the way. So Rachel, I'm going to point to some numbers with my big button here and just ask you to just say them, okay?
Yep. 3, 4, 6, 7.
Oh, that didn't work.
8, 2. All
right, and so obviously we're just looking at the ones in the top row initially. Thanks, Rachel. And it's a whole class oral chanting. So we start really tight when we're getting to know the Coutinho chart. Let's try some other ones, Rachel.
200, 400, 700, 400, 300.
Okay, and so we can look at the different rows and get used to that. Now, this time, Rachel, I'm going to point to two numbers and, well, I'm going to tell you, I'm going to point to 3 and 6. And what I want you to say is 3 and 6s, and then I'll point to the total, okay?
3, 6.
So I want you to say the number sentence, 3 plus 6.
3 plus 6 is 9.
Yeah, I'm trying to move to the 9 there, but I've got the photos in the way. Maybe I can move them there. That's better. Okay, and now let's try these ones. Go.
30 plus 60 is 90. 300 plus 600 is 900. 3,000 plus 6,000 is 9,000.
Okay, so after doing something like that, obviously you can have some great discussions about the patterns that are happening there, and the teacher is supporting the whole way. It doesn't say so in the article, but what I'm imagining is at some stage, you definitely do print out a copy of the Coutinho chart for every student. Imagine that, they could do some of those simple ones with their classmates. The whole idea is, if I know, if I know that 3 plus 6 is 9, then I know that 3,000 plus 6,000 is 9,000. Okay, algebraically, what's actually happening here? 3 plus 6 is 9. 3x plus 6x is 9x. 3x squared plus 6x squared is 9x squared. 3x cubed plus 6x cubed is 9x cubed. Now, I wouldn't necessarily go in and say that. I wouldn't say it in the first lesson, but this is what we're actually doing here. So that's pretty exciting. Now, the next thing that Alf did was multiplication and division by 10. So Rachel, I'm going to ask you a different question now. I'm going to point to some numbers, and what I want you to do is tell me the number that's 10 times greater?
You want me to do it?
Yeah, if you can say the number that's 10 times greater.
10 times greater than 4 is 40.
Good. And so just say the total. You don't have to say the equation this time. Okay.
60.
Good.
900.
Good.
500.
Good. And now I'm going to show you some numbers, and I'd like you to tell me what's 100 times more than this number.
600. 700. 8,000. 3,000.
Right. And so now we'd explore and we'd talk about the fact that that in terms of the chart, when we multiply by 10, it's like we go down a row, and when we multiply by 100, it's like we go down 2 rows, and then we can naturally lead into the reverse. So Rachel, can you say this number divided by 10?
20. 10. 70. 5.
And now we'll give you, these are the last ones, 4 numbers, and can you divide by 100?
5. 60. 30. 9.
So again, we're talking about division. The division is going, if it's division by 10, going up 1 row, and division by 100 going up 2 rows. Now, at this point, Alf got the kids to go on their own mathematical journey, and this is what they were asked to do. They were asked to choose a number. So this student's chosen 600, and to go on a journey multiplying and dividing by 10 or 100, whereby they ended up back at the start. So they went 600 multiplied by 10 equals 1,000. They recorded the journey, divided by 100, 60, and multiplied by 10, 600. So they all went on their own individual journey. They did some exploring. And they were all asked to write down what they noticed, or if they had any questions. So this person, they had their own journey. They said, I've noticed it is clever, because if you divide by 10 and you multiply by 10, then you get back. That's a huge discovery. This learner multiplied by 10, multiplied by 10, multiplied by 10, multiplied by 10, and then divided by 10,000. And their comment was, I went back and won. So this became an interesting explore for a lot of the other students. Could they go on a journey to go somewhere else? And then could they get back to the original in one move? So these are students coming up with their own explorations and their own ideas about what they want to do. Here's another one where they went into decimals, because this is the full Coutinho chart. So there was just a lot of great discovery that happened there through challenge. And if you want, Twinkle have 5 short examples on a YouTube clip on how you can use the Coutinho chart. I think the work that Alf did was really exciting. Natalie in Canada, she had English speaking students who were in a French immersion class. And so they were learning the language of large numbers very quickly. And that's another exciting sort of possible way that you can use this as well. Very powerful. I'm not going to talk about substitution. Thanks for coming. The recording will be available on the AMA website, plus the PDF of various videos, articles, and follow-up ideas to support you.